All right, so I want to do this problem. I want to do integration via u substitution. So what I'm going to do is I am going to use u substitution to find the indefinite integral here. Okay. So how do I know that I can use u substitution? If I look inside this parentheses, so I have here the indefinite integral of 3x squared sine of 5x cubed plus 1. Now, how do I know I can use u substitution? In my head, I take the derivative of this expression inside here. Right? I take the derivative of this expression inside here. And what I do is, when I take a derivative of this expression inside here, I know that that's going to become 15x squared plus 0. Okay, so I can forget about the 0. Now, I have here 3x squared. But if I think about the x and the exponent of the x, as far as the x and the exponent of the x, I have the derivative of what is inside here. Now this 3 is not part of the derivative, but I can maneuver that later on. You will see how I do it to actually successfully use u substitution in finding this antiderivative. Just let me get started with that. So I'm going to let u, because I noticed that if I take the derivative of this inside here, as far as x and the exponent is concerned, the derivative is here, I am going to let u equal whatever is in here. So it's going to be 5x cubed plus 1. And now what I'm going to do is I'm going to take the derivative of this in respect to x. So I'm going to do that du dx. And of course, this is going to become, as I said earlier, 15x squared. Okay, well, I am going to now, because I have a dx here, I'm going to multiply both sides of this expression by dx. So this is going to imply that du is equal to 15x squared times dx. So there I have that. Okay, yeah, that's great. But I don't have here, I have certainly x squared times dx. I don't have a 15. Well, you know what? I can divide both sides of this expression by, I'm going to divide both sides of this expression by 5. So I'm going to divide this by 5. And I'm going to divide this by 5. When I divide this by 5, this side, let me do so. This is going to become 3, because this is 3 times 5. So the 5 will cancel out, and I will be left, okay, just with the number 3. So I'm going to put my 3 in here. Right, so this is my 3. So now what I'm going to do is, I'm going to go back here and look at what I have here. I have here 3, then I have the dx, which is here. So I have 3x squared dx, both of which are present here. So that means that I can replace, so this implies the following integral. This implies the following integral. Since I have this 3x squared dx here, and that this, according to what I just did, equals to du divided by 5, okay, so I'm putting here du divided by 5, and you know something, this du divided by 5, I can actually put this outside the integral. So let me just multiply by 1 over 5, and I am just going to erase this from here. And I might as well, I'll do this again, sorry. So I have here du, right? But I'm not done, because I have here sine 5x cubed plus 1, but that is just sine u. So I'm going to write sine u here. So now I have the integral 1 over 5 of sine u du. Well, that's pretty nice. Because I know the antiderivative of this. The antiderivative of this is going to be equal negative cosine of u. So this actually, this over here is going to be equal to 1 over 5. This is going to be equal to 1 over 5, okay, or rather negative cosine of u plus the constant c. I want to define constant. Okay, so I have found the antiderivative of this, okay? But I am looking for the antiderivative of this. Well, it turns out that from here, from right here, I can get the antiderivative of this. So what this over here tells me, okay, what this is telling me here, this over here, right? Let me highlight this. Tells me, okay, that this expression here, the indefinite integral of 3x squared sine, okay, 5x cubed plus 1 dx is just equal to negative 1 over 5 times cosine of u, but u is 5x cubed plus 1. Okay, so you got to remember that q is equal to that, right? So it's 5x cubed plus 1. And then, of course, this c has to be added here because we're looking for the indefinite integral. Okay, so there we have it. So this is the way you integrate using u substitution. And I will do some more problems later on. Thank you for listening.